Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all staying warm. It's pretty cold here right now. It's, what is it, minus 35 overnight, and it warms up to minus 25 Celsius during the daytime. So yeah, it's a good time to stay inside and work on the bench. So anyways, today I have a Harman Kardon A402. This was brought to me from one of my clients. He brought me a group of amplifiers, 3 Harman Kardons, Kenwood, and I already did the HK560, and that's a beautiful sounding machine. But we're going to tackle this one now. He says this one has a scratchy left channel, or intermittent, or it's something wrong with the left channel. So we're going to try it out here. Power it up. We have no bulb action there. A little bit of DC on the output, not much. It's probably normal from sitting. It's kind of fading to nothing. So yeah, when you have an amplifier that sits for a long time, it kind of has to wake up first. Okay. So I'm on phono right now, phono 2. Let me shut this off. My signal generator is bleeding through. That's full volume. That's a little bit of a scratch on the volume pot. Pots are clean. Maybe he cleaned them himself. I noticed the bass control is bent, and this function control is also bent. It's got a good hook to it. I don't know if you can see that. Watch. Okay, so I'm not hearing anything. Okay, everything seems normal. Let's feed it. Tuner, silent, auxiliary 1. No left channel. Oh, there it is. It has a distortion in it too. It doesn't sound good at all. Let's hook up a scope and see what that looks like. Alright, got a scope hooked up. Let's power it back up. Turn on speakers 2, turn off speakers 1. What is going on here? Oh, okay. Got both channels going. Let's turn this up. And you can see the left channel is the top one. It's got some heavy distortion. Really heavy distortion right into clipping on the right channel. Left channel's not even keeping up. That looks terrible. So what is that? I'd say it's probably bad caps, bad transistor. Who knows? It's having a hard time keeping up. Let's turn off the right channel. Take it into clipping. Yeah, it's not. It's a sick puppy. Okay, well, what I should do is I'll feed a signal directly in to the power amplifier. All I got to do is switch my leads around, take the links out, and feed it directly in. I got to turn my amplitude down first. turn it to 0. Where's the inputs? Right, left. Okay. So let's try this again. We have power is on. Let's turn up the amplitude. Yeah, and we're getting that distortion. There's something going on in the power amplifier that is not right. Okay. So now we know where to look. So I was out shopping the other day and I went to treat myself. I went and bought a new screwdriver. Look at that. Isn't that beautiful? I love the ruby color. It's from gearwrench.com. I don't know if that means anything to anybody, but it's a virgin tip. So here it goes. Gonna break the cherry. Sometimes if you get a dull screwdriver, it really messes up the Phillips. This one really fits nice. Okay. Not that it makes much difference. These are my old Klein screwdrivers, and these are 40 years old, and they're starting to get a little dull in the tip, but they're fantastic screwdrivers. I love the grip on these, but I just wanted to give this a try. It was $10, so why not? I tried to treat myself for once. Okay, let's pull the lid off. Okay, let me reposition the camera so you can see what's going on here. So here it is, just as I remember it. Twin powered, it's got 2 power supplies, just like the 730. It's a power amplifier module here. This is a phono stage, phono equalization stage. Switching and inputs back here. Here's our tone amp, front, top. And we have 2 boards here that are switching boards, the tone, the high cut, low cut filters, contour, loudness, dubbing, and tape monitor loops go through these 2 boards. It's kind of complicated in here. Then there's 2 boards here for the display. There's one for each channel, and a little board here for speaker switches. So let's I have a sneaky suspicion that's one of these caps in the power amplifier. So let's pull out the power amplifier, and just for the hell of it, let's test some capacitors and see if we can spot which one it is. I think it's left channel. I'll have to figure out which side left channel is. I think its board is marked. If I tell you the truth, I think it is. So let's pull this board out and we'll have a good look at it. Alright, so here we are. I took the bottom off, have a look inside the bottom of the unit. Power supplies. Here's a power supply board here. This is a little supply that I think it supplies 12 volts to the phono equalization preamp and the tone board, the preamplifier and tone board. I don't think it draws much current. I think it's like not even an amp, not even that. And you can see the underside of the display, the switches, and a lot of cabling for the different inputs. Selector switch here, it's a wafer switch. Anyways, here's the power amplifier. And it is marked here right out, left out. Okay, so we know that this side is the right side, this is the left. And looking at this, I happen to think this capacitor is bad. This is the, it's 100 microfarad, 10 volt. And this is the DC blocking cap on the input of the power amplifier. So let's check the right side first. Let's see if I can get this in frame. Can you see that? Yes, you can. Let's check the right channel first. It's 100 microfarad at 10 volts. It should be ESR of 1.2 or less. Let's see what we get here. And we get 0.65. On this channel we get 0.65. So I was wrong on that prediction. Let's try this other cap here. This is a 10 microfarad at 16 volts. I don't know if I can get at it here. Hang on. Is that right? 2.5, okay. And this one on this side. 2.7. It's starting to look like it's not a capacitor. What else could be wrong with this thing? Let's check the big one, the 1000 microfarad at 10 volts. 0.3, 0.29. It's not great for 1000 microfarad. The other side. 0.22. Wow, so what is going on with this thing? Could it be we got a bad transistor? Didn't look like a bad transistor. Could be a cracked solder joint too somewhere. That could be another possibility. I'm going to have to pull this all apart and what I'm going to do anyways, like this heatsink grease is all dried up. It's all powdered. Completely dried up. So we're going to have to change the micro washers to sill pads to clean this up, and because right now it is not good. When the silicone grease dries up and turns to cake, it's not doing its job. So pull this all apart. Somebody's been in here already once. Looks like there's different screws. Maybe not. Maybe not. See, even the heatsink compound on these is all dried up. It's completely dried. Alright, so I was poking around this amplifier circuit here on the right hand side. This is the left channel, this is the right channel. I went through and I checked all the values of the resistors. They're spot on. Previously checked the ESR on these caps, they were good. I'm going to replace these anyway because they're old, 45 years old, and they are quality Elna caps. Elna makes good caps back in the day, but I think they're done for. They're going to get changed, and just so that everything's balanced between the channels. So I was trying to figure out what's going on with this amplifier that's making that noise or that distortion, and I think I figured it out. I was going through doing some diode checks on some of these transistors, and this driver here, Q414, didn't behave properly under the diode checker. So what I did is I took it out and checked it again. Let's try it again. So we got emitter, collector, base. So the base should be my common lead here. I'll put the probe on. It's ceramic. put this on base. Collector to base is open. Base to emitter is open. Okay, so let's switch our leads around because we might have them backwards. Let's try this again. Base to collector, open. Base to emitter is open. So this is like a wide open transistor. So I took this little device and plugged it in. And I don't know if you can see this. I'm going to try and get this so that it's... Okay, lock this down. And when I press the button, you should be able to see what it says here. Tests like a 30 picofarad capacitor. So this transistor is open completely. And that's the cause of our distortion in the left channel. And I'm surprised it didn't take out more damage here. I'm going to have to check the TO3 transistor as well. But as far as I can see, that one was working. It was working on the half cycle. This one's open. Let's try. Which one is this? This is, we can do this right now. Oh, another thing. I took the transistors out, and this is all just dried up cake. It made a huge mess. It's all powdery. You can see the powder here are on the screws. Transistors, it's all falling apart. It's just garbage. See this powder? It's all dried up, caked. So yeah, it's a good thing we got this in time. Okay, so we want, for this transistor, we want 2SD581. And I noticed that the transistor numbers don't match the board, which isn't a big deal, but let's take this apart. This is a mess. Okay, you got a dial check. Which is base, by the way? I can't ever remember on a TO3 which is the base. Okay, this one here. So let's check this transistor out. We might have to replace it if it's bad. Okay, there's our base to collector. Base to emitter. Everything looks good on that one. Let's find the other transistor. Which one is it? 2SD. Maybe I got this backwards again. Base to emitter. Base to collectors. Those two transistors are good. That's a good sign. So we just got one dead transistor here. It's a 2SB549. Interesting. I have to check these other ones too while I'm in here. And I also got some circuit glue here around. I don't think this is causing a problem, but I'm going to remove it all anyway. Circuit glue around these big caps. And then we'll clean it up, put it all back together. Another problem I noticed with the Harman Kardons of this type is they have these TO3 sockets, and the heatsink compound gets into the pin connector here. So you got to flush these pin connectors out with some kind of a aerosol spray, just to flush out that white chalky residue. And then I'll clean everything up and then put it all back together. I'm going to disassemble this and re-goop the transistors on these as well, because they're all dried up. Everything's dried up here. All the heatsink compounds dried. Alright, so I'm making some good progress here. Got the new transistor in. I took these apart and cleaned them and put them back together with sill pads. The mica washers under one of those was completely disintegrated. So it's a good thing I did that, I guess. Still things I want to do. I want to put 10 turn pots in for the two trim pots, the bias trim pots. I'm going to put two 10 turn in. And new caps. There's one thing here that's got me kind of confused. There's somebody, this is done at the factory. Somebody tacked in a 560K resistor across the 120K, and that is right here. Let me show you where it is. find it on here. It's not on the schematic. So this 120K right here, somebody put a 560K in parallel with this to drop this. So I measured the resistance of this. It's around 95K now. And the other channel, if I measure the other channel, it's right at 120. So I'm wondering why the factory did that kind of adjustment. This circuit here, this line that comes down from up here, well actually let's go up here. This little circuit here is a timing circuit, and this provides the power on delay, a 4-second power on delay. So when they turn the power on, these capacitors take 4 seconds to charge up before this transistor turns on and signals the amplifiers to go into conduction mode. So this comes down here. There's a steering diode here, another steering diode down here, same circuit. And there's a little Zener diode here, and this sets regulation for this transistor. But for whatever reason, they're changing this value from 120K to 95K. I'm not really sure why they did that. So I'm going to remove that resistor, and I'm going to try it without, and we'll see how this works. If I can measure the current through this resistor, through this long tail pair, and as long as they match, right? As long as they match this current and this current, I think we're good. They probably did it for, I don't know what reason they did it, but maybe they were matching transistors or trying to match current through these transistors. But I'm going to see how this goes once I power it up. And if I deem necessary, I'll tack it back in. If not, I'll remove it. Got the heatsink all cleaned up. This was a pain. What I found works good is WD-40, and you know, just a paper towel with WD-40, and it just takes that stuff right off. It's good, but there's still some here. Somebody must have had a really bad day when they were on building this amplifier, because it just slopped that crap everywhere. It was all over the parts and the heatsink and you name it. Okay, so yeah, caps are done. I still want to change these 2 trim pots, and then I can put it back together. Put the transistors back in, main power transistors. And well, first I'll clean this all up, and then we'll reassemble. Okay, time for updates. Tone board and preamplifier. I've gone through and I replaced all the caps on this one. I did find some weak capacitors on here. Not all of them, but like these 1000s were okay. These 220s were okay, but I replaced them anyways just to cover all bases. So it's going to be good now. A lot of these smaller ones were replaced with audio grade caps. And I went and replaced all of the transistors on this board because they are all the 2SC 1345s, I think. Let me see here. 1345s. I don't know if you can see the legs have oxidation on them. And this is the whiskers, the silver whiskers. These would be problematic sometime in the future, so that's why they're gone. Here's another one that looks really bad. They grow these whiskers on the legs, and it's a function of having a potential difference between the different legs, and it's kind of the whiskers grow as kind of like a electrolytic process. See, they rub off. You see the black, and that's silver. Because these legs are silver plated, and the silver oxidizes, and it eventually the whiskers make contact with each other and short out and cause hissing, popping, scratchy noises. So it's good just to get rid of them today. Pots are cleaned, switch is cleaned, board is cleaned. I didn't think I did anything else to this. Now it's ready to go back in. I'm turning my attention to the switch now that's broken. You're going to have to replace this because there's no other fix for it. You can't just glue on something that's not there. So I'm going to remove this and replace it with a new switch. I treated the other switches. I don't know if somebody sprayed the switches before me. Sometimes I can tell if it's got, you know, if you got oily residue. Sometimes it's apparent, sometimes it's not. Sometimes they spray in contact cleaner and it flushes everything out, the lubricants, everything, and it's completely dry inside. And that's not good either. So what I'm using is this diagnostic. And this is probably the best stuff you can use for switches. I wouldn't use it on pots, but I think this is excellent for switches. And it's got the cleaner and the diagnostic all in one, so you give it one shot and work the switch, and then it cleans and lubricates all in one step. Okay, so we got this to go this way. And I got too much on it, getting it on my fingers. Now, for a cap, I have these. These are not original. These I had somebody made these for me, a machinist, actually my son. I asked him to make me a bunch of these, and these are replicas of the originals. Now they don't have the same finish. See, they're not as nice. They're kind of coarse, but it's better than nothing. And that's what I'm going with. I'm not going to put it here. I'll put it on another switch where it's by itself, and then you can't really compare. It's not easy to compare the difference between them. But this will have a cap on it when I'm done. So it's just a matter of I still have a little bit left to do here. Let's have a look at the rest of it. Power filter caps, I tested these, and these are pretty much bang on 4700 microfarads, and they still have good ESR. So I'm going to leave these alone for now, and I'm going to do the power test, and I'm going to see if they cause a problem on the power test. And but for right now, I'm leaving them alone. All right, so everything's back together again. It's looking good, and let's hope it sounds good. It should. Got everything fixed up in the power amplifier, tone board, preamplifier, tone circuits are all recapped. Phono equalizer is recapped as well, so it should perform stellar. So let's do a bias adjustment. Get this now. I turned it on for the first time. Hope we get no smoke. Now we're good. The instructions, or the procedure in the service manual says to measure across resistor R435 and measure 15 millivolts here, and 436 measure 15 millivolts here. But the method I do is I measure across the two collectors, the two output transistors, and that has these two resistors in series. And what I would do is I just double the voltage from 15 millivolts to 30, and I measure across the two collectors, and that'll be satisfactory. Let's get this connected up and see what we have here. Okay, so we're down around 4 millivolts. Let's turn this one up. Before I start though, this thing's dead cold, and I'm drawing 16 watts from the outlet, which is very low for an amplifier this size. So let's turn this up and we'll see if we can get it up to 30. Now probably what I'll do is I'll put it up around 25 and then let it stabilize, and then I'll come back and I'll check it again. Because once I turn the current up, the heat sink's going to start warming up, and the bias is going to change. So like I said, I'll put it around 25, which puts it at about 12.5 millivolts across this resistor. So I'll just let that cook for a while. Let's do the other one. The other channel. And what do we got here? 10. Turn this one up as well. And then we'll just let this idle for a while. And temperature stabilize. Close enough. One thing I want to do is check for DC on the outputs. So, now we're going to do this, are we? This is the left channel. And am I on speaker? No, I'm on the wrong speaker here. Okay, left channel. You got 2 millivolts, right channel. 4 millivolts, 3. Pretty good. No complaints there. I'll leave that. Alright, so about 20 minutes later, I didn't quite land it, but I got pretty close. It's almost at 29 millivolts, so let's just crank it up a little more. And then we'll leave it at that. A little too far in it to back it off now. Okay, I'll leave it at that. This one's a little high. I'll back this one down. Okay. I'm going to check current power consumption, and we are at 20 watts, which should be about right. It's not a real power hog, this amplifier. It's alright, so now let's connect up a load and the signal source, and we'll do some power tests. We'll finish this one up for the day. Alright, so we're wired in. Got my 8 ohm load. I'm feeding it 1000 hertz tone. Let's turn it on and see what we get. Anything at all. Turn up the volume. And I do have it on number 1. Turn on my signal generator first. Here we go. Okay. Left channel is a little higher than the right. Okay, so I'm going to leave it right there. I'm measuring the left channel. I'll put clipping on the left. Just at the verge of clipping. Right about there. And we've got 20.29 volts RMS into 8 ohms. I'm going to let this go for a while. see how it runs stable or not. So let this cook for a while. It's not even warm yet. But my load is hot. So let's say everything's looking good. Okay, we've had it on for 5 minutes, full power, and the heatsink's just starting to get warm. It's not warm enough that I can't hold my hand on it, but it's about 40-50 degrees Celsius. And good news is the transistors are not any hotter than the heatsink itself, so that the thermal pads are doing their job, transferring the heat and keeping those transistors cool. Another thing I like is these driver transistors are not, they're barely warm. So looks like overall it's a nice stable amplifier. It's not doing anything bad. But it's, like I said, it's been on for what, 6 minutes now, and still chugging along. So I think it's proved this point, so we're done with that. One thing I want to do is check square wave, so let's switch the signal around here. Square wave, turn it up. Square wave is a good indication of how an amplifier behaves, its frequency response, and if it does any ringing or oscillations. So I can see a little bit on the trailing. These little transistors are having trouble shutting off. Looks like something is going on there. Let's see what that is. Or maybe it was just an artifact of the scope. That looks like a damn good square wave right there. It's full power. Yeah, it is a little bit, it's having trouble turning off those transistors. Okay, I don't want to do too much square wave. That's a torturous thing for an amplifier, but it's looking pretty good. And that's what the tone controls shut off. Let's turn the tone controls on. This is bass, bass cut, bass boost, treble cut, treble boost. Oh, a little bit scratchy there. I'm gonna have to work that knob. Oh, it's working really well. Okay, I think it's done. All right, we'll wrap this up. So, what parts did I put in? Not a full recap, but I did replace quite a few of them in the amplifier circuitry. A lot of these bigger caps were fine, so I left them alone. Some of these are still good, and I replaced them anyway. Replaced the broken switch. I had the plunger broke off, so that's done. Replaced a burned out bulb for the power switch. Replaced that with an LED circuit. Replaced the mica washes with sill pads. And I have probably, oh, here's the bad transistor. This was in the power amplifier. This is the one that caused the distortion and the original complaint from the owner of scratchy left channel. So that's the problem there. And then I replaced 2 trim pots. I just like replacing these because after 45 years, these things start to go flaky and they get dirty just like a regular pot does. And when you're trying to do adjustments and it's flaky, you get your adjustments can be all over the place, and they can even go open, which could grenade your amplifier. You don't want to do that, so I usually just replace these. How many transistors here? I replaced a few transistors. 1, 2, 3, 4, 5, 6, 7 or 8 of these little 2SC 1345s. These are problematic. They develop silver whiskers, and then they develop shorts and create noise over time. So yeah, a fair amount of parts went into this, and it's going to be a nice amplifier now for the owner. It's going to be a great sounding device. I'm going to look forward to hearing this one. So there it is, it's all done. It's a treat to work on. I love working on these older ones. They're well laid out. A lot of thought went into the construction of these. They're built like a tank, and they're very, very well built. Very high quality construction on these. Very, very rarely does anything go wrong with them other than switches and pots. And in this case, we had a transistor that was open, which is kind of confusing because usually when transistors fail, they fail into a short. But this one was completely open, so I have a feeling it was maybe from heat cycling, thermal cycling. Maybe a bond wire broke or something inside, and that's what ended the transistor's life. But it's fixed now, and it's working pretty good. It's going to be a treat to listen to this. I wonder if it sounds as good as mine does. But I'm sure it does. And I'm sure the owner's going to be pleased to hear it too when he gets it back. I don't think he's ever heard this before. I think when he picked it up, it was damaged in that one channel. So it's going to be a treat for him as well. So I'm going to end it here, and take care. Thanks for watching, and we'll see you on the next one. Lots more coming up, so stay tuned.